Hi, my name is Adrian Vicente and this is my tutorial on molarity for Introduction to Chemistry. So, let's talk about molarity. What is it? Well, molarity is a measurement of concentration. Specifically, it's a measurement of concentration of solutes in solutions. So it measures how much of something is dissolved in something else. If you look around in your lab or like at the bottles full of the liquids with like iron something, you'll see that usually they are measured in terms of molarity. Molarity is denoted with a capital M. And if you've seen this capital M, then this is what it means all along. Now you know. So before we go any further into molarity, we should first discuss the formula of molarity. And yes, there is a formula, but it's very simple, so you shouldn't be too worried. So molarity, again denoted by capital M, equals the moles of the solute divided by the liters of the total solution. And so, again, molarity is just a very simple method of measuring the concentration of substances and other substances. There are different ways to measure concentration. There's mass percent, there's mass over volume percent, but again, this is the one that's most commonly used, especially for solutions. And it's very simple. Molarity just tells us how many moles of a substance there are per liter of the entire solution. So, two important things to remember when using this, when calculating molarity. One is that we are talking about the moles of the solute, but what people commonly forget is that we're talking about the liters of the entire solution, not just the liters of the solute. So it's important that they look at the total volume of the entire solution. Second, it's very commonly people fumble up molarity and moles. They think that maybe they're one and the same, or they mix them up because they both sound very similar. And again, many students are used to shortening the, moles, which is an M, but then in fact molarity is with a capital M. So this can be pretty easy to confuse, but it's important that you always keep in mind that you don't mix these two up. It's important to remember that molarity is absolutely not the same thing as moles. In fact, it's better if from now on you just write out moles instead of trying to shorten out that measurement. So, all that being said, again, it's a pretty simple rudimentary formula. Let's apply it in a problem and see it work out together. So, what is the molarity of a solution formed from 6.75 grams of sodium chloride dissolved in water to make a solution with a total volume of 452 milliliters? So what it's asked. So first, because we've memorized it, we're going to write down our formula. It's molarity equals moles of the solute over liters of the entire total solution. So, again, it's asking us for molarity right here, a big variable, which is nice and comfortable. We can use that. So we're going to bring this down. That's what we're looking for. We have 6.75 grams of sodium chloride. So this is what we're going to be converting into moles. That sounds tough, but don't worry, we've been doing it in class already all year. So this shouldn't be too hard to calculate. And it also gives us our volume. But there's a problem here. This volume is in milliliters, and that's not what we need. What we need are liters. It's very close, but it's not what we're looking for. So we're going to have to convert this quantities. But we know that there are 1,000 milliliters in every 1 liter. So by dividing this by 1,000, we know that our solution has a total of 0.452 liters in it. Okay, that means we have half of our whole formula down already. See? It's not so bad. But now we go into the slightly harder part. We have to convert 6.75 grams of sodium chloride into moles and put it on top right here. So let's get ready to convert 6.75 grams. And we're going to convert this into moles. And we've been doing this since the beginning of the semester. What we're going to need is our molar mass, which I've already found and calculated right here, but I'm not always going to be here to do that for you. So be prepared to bust out your periodic table. And so we have our key right here. We're going to put grams on the bottom. We know that there are 58.44 grams in every 1 mole of sodium chloride. And just a simple division, we're going to be able to find our number of moles in the solution. I'm going to bust out the calculator. 6.75 divided by 58.44. And we know that we have 0.116 moles of sodium chloride in this solution. Okay, now we're just going to take this and punch it into our formula over here. Great, so we've set up our whole formula. That wasn't so hard, just two things we had to figure out. That wasn't even that difficult, really. So now we just got to do the math and find our molarity. So 0.116 divided by 0.452 liters gives us a molarity of 0.257. And that is our molarity of sodium chloride. Yeah, 6. So, see, that wasn't so bad. It's really not that hard of a formula, and it's pretty simple when it comes down to it. Sometimes, they may give you the molarity and they may ask for the volume, or for the moles instead, or for grams, in which case you're going to have to work this around a bit. But it shouldn't ever really be that hard. Just a little bit of algebra, you'll be fine. Just remember, important thing, we're talking, when working this formula, talking about moles of the solute and liters of the entire solution. This is arguably the biggest mistake that people make, alongside with molarity over moles. As long as you remember those two things, you should be fine. And yeah, that's my tutorial on molarity. I hope this will be able to help you. This is Adrian Vicente, signing out.